All right, so number one, are these two triangles similar? Did it come out to be similar or no?
Yeah.
Yes. We match up smallest side with smallest side, so that would be the 6 and the 4. And then we match up the medium sides together. That would be 12 and 8. And then the largest sides, 15 and 10. When you simplify each of those fractions, you get 1.5. If you set it up the other way, you would still get 3 equal amounts. It would just come out to be something different because it would be the scale factor for the reduction instead of the enlargement. So yes, by side, side, side similarity. And then it says write the similarity statement. So my similarity statement here would be triangle JKL is similar to triangle NPM. Number 2, you wouldn't use side, side, side on this one. We have vertical angles. And then we would set up our proportional sides. 2 over 3. Is that equal to 2.5 over 3.75? Did this come out to be similar? Yes. We get 0.6 repeating and 0.6 repeating. The other way around it would be 1.5. So yes, by side, angle, side similarity, I would have triangle WXY is similar to triangle VZY. All right, so those I saw a lot of really good work on. Number 3 is where a lot of us were getting confused though, so I want to walk through that one a little bit slower. So we've got 2 different triangles here. There's this little triangle here. I'm going to draw him separately. We know that this side is 2 and this side is x. And then there is the larger triangle where this side is 7. How big would the bottom side be? 3 plus x. You would have to add these 2 together here. So then our proportion of sides, x would correspond to 3 plus x. So I would have x over 3 plus x is equal to, and then this would be my other proportion, 2 over 7. Then we multiply to get rid of our fractions. So I'd multiply both sides by, it doesn't matter which denominator I select first, so I'm going to multiply by 7. That only distributes up to my numerator. So I would have 7x over 3 plus x equals 2. And then we would have to multiply by the other denominator, 3 plus x. So the 2 would have to distribute here. So I would have 7x equals 6 plus 2x. Then I would subtract 2x from both sides, giving me 5x is equal to 6. And then I would divide both sides by 5, giving me that x is 1.25. So we're going to practice a lot more today with this idea that you have to add to get that big side, but that was the big idea on number 3 that was the key to solving that problem. All right, go ahead and pull out your extra notes. Extra notes packet today, yes. We'll be in just the extra notes packet today. We finished problem number 2 yesterday. We're going to look at problem number 3 to begin with. Again, we are on page 8, back side of the 4th piece of paper. Down at the very bottom. Yes, that page right there. We did the top 2 pieces yesterday. Yep. All right. Number 3, it says we have a triangle called LMN. So on this blank triangle over here, let's go ahead and label that up. I'm going to do LMN. Then it says it has midpoints. It has a midpoint of A on segment LM. So here would be my midpoint A. That means that MA is the same size as LA. And then it has another midpoint B on MN. So B would be somewhere down here. And MB would be the same size as NB since it's a midpoint. Let's go ahead and connect those two midpoints together. What do we call a segment in a triangle that connects two midpoints? Midsegment. That is part A. All right, let's see what else we have to work with here. Part B, AL is 62. Here's AL. MB is 3x plus 11. And then MN is 2x plus 55. We need to find some relationships here so that we can set up and solve an equation to find x. What did we say B was again? Midpoint. What do midpoints do? Cuts it into two equal parts, cuts it in half, right? So what kind of a relationship could we use to set up and solve an equation? Yes? Oh, yes it does. AM is 62 also. NB would also be 3x plus 11. I want that to be the case, but we don't know that we have an isosceles triangle, so we can't add these two and set it equal to this. But I do see two things that we could add together and set equal to 2x plus 55. Yes. MB and BN. If I add those two segments together, then I get that big long segment, right? All right, so MB plus BN equals MN. We were told that MB is 3x plus 11. Because B is the midpoint, we were able to then figure out that BN would also be 3x plus 11. And MN is 2x plus 55. Yes. All right. So you could do it like this, or the new suggestion, which is also correct, you could do 2 times MB is equal to MN, because that would have us adding 3x plus 11 twice. And set that equal to 2x plus 55. Whether we choose to use the multiplication way or use the addition way, we should get to the same place in the next step. So I would take this 2 and distribute. That would give me 6x plus 22 is equal to 2x plus 55. If I was doing the other way, where we just add those two segments together, we would have to make sure to combine our like terms. 3x and 3x together, 11 and 11 together, so I still get 6x plus 22 equals 2x plus 55. So these are exactly the same. It doesn't matter which one I solve from here on out. So it's going to be this exact same thing. What do I need to do after I get it to here? Yep. Okay. So I got it to this part. Yeah, I combined these two pieces to get 6x and these two to get 22. It's the same thing I got when I distributed over here. Subtract 2x from both sides. Let's get our x's to the same side. What is 6x minus 2x? So 4x plus 22 equals 55. And then? Yep, we're going to subtract 22 from both sides, so it'll cancel out on the left. On the right, we have 55 minus 22, which comes out to be 33. And then for my final step, to finish getting x alone, we're going to divide both sides by 4. What is 33 divided by 4? 8.25. Very nice work on that one. I like that we had multiple approaches to be able to solve that problem. Because you can't do this. They're on the same side. You have to combine them. So that would be 22 instead of it canceling out. All right. Part C, last part of this question. We have ln is 200 plus 2w. That's this piece right here. And then AB is 43. What did we call segment AB again? The midsegment. And yesterday we learned two properties about midsegments of triangles. What's the relationship between the midsegment and the third side? So between AB and LN, what kind of relationship exists there? AB is half of LN. The other property is that AB and LN are parallel. So AB is half of LN. How big is AB again? 43. So 43 equals 1/2 of, how big was LN? 200 plus 2w. And now we have to make a choice. Most of the time when I have parentheses and a number out in front of those parentheses, we're going to distribute, which I could do this time. I can distribute that 1/2. I don't like distributing fractions if I don't have to, but we can if you guys want to. The other option is that we get rid of the fraction. So do you guys want to distribute the fraction or get rid of the fraction? Distribute, okay. So distributing that fraction, I would have 43 equals, what is half of 200? 100. What is half of 2w? 1w. So now I have 43 equals 100 plus w. And to finish getting w all by itself, I need to do what? Yes, we're going to subtract the 100 from both sides. We're going to remove it from the side where w is. Negative 57 is equal to w. Very nice work. Uh-huh.
Why couldn't you just subtract 43 from 100 and it'd be positive 57?
Because then you would have, let's look at that right here. So if we did 43 equals 100 plus w, if you subtract the 43 from both sides, this cancels out, but that does not mean it goes away. I would have 0 equals 57 plus W. So I still don't have the W all alone. That's a really great question. If you subtract all of one side of the equal sign, it doesn't disappear. The equal sign doesn't move. You just have a 0 over there. Good questions, good questions. I want to demonstrate just real quick. Since this was not the choice that we made, but sometimes it's not so convenient to distribute a 1/2. Here I had 2 even numbers, so finding half of it was really easy. If you guys had decided to get rid of the fraction, what operation gets rid of fractions? Multiplication gets rid of them. What part of the fraction do you multiply by if you want to get rid of it? The denominator. What's on the bottom of this fraction? 2. So I would multiply both sides by 2. That would multiply to my 43 here. The 2 that I multiply by would cancel out with my denominator, so technically I'd still have a 1 that needed to be distributed. Yep, I would get 86 equals 200 plus 2W, and then I would solve it from there. It comes out to be the exact same. It's total personal choice. I like to show it both ways because some people see fractions and they're like, they get frozen. They won't move forward with a problem. So there is a way to do it without fractions. If you don't mind working with fractions, yeah, you can just distribute that and move forward. You pick whichever way you like best. Let's go ahead and flip the page over.
You still get the same answer?
You get the exact same answer either way. No. It's a valid question. All right. Number 4, we're supposed to find the values of x and y. And we don't even have triangles here. We have parallel lines. So let's talk about some relationships with parallel lines here. I see an x right here, and I see an x right here. I know there's one over here too, but I'm going to focus on these guys because they're on the same side. They're both over here on the right. And I noticed something about these 2 segments. The one marked 2x has this 1 congruence mark on it right here. And the one marked 4x minus 10 has a congruence mark on it there. What do we do with things that are congruent? Set them equal. These are congruent, so we're going to set them equal. So I would have 2x equals 4x minus 10. No fractions at all. Where do I want to go from here, though? Subtract, yep, we'll subtract 4x from both sides. So it'll cancel out over here on the right. What is 2x minus 4x? Negative 2x. Make sure you get that negative in there. On the right-hand side, also don't forget the negative here. That 10 had a minus sign in front of it. That minus sign didn't go away, so it's got to come down. So I have negative 2x equals negative 10. What do I need to do now to get the x all alone? Divide. What are we dividing by? Negative 2. And a negative divided by a negative makes it a positive. So since it's negative divided by negative, I do positive 10 divided by positive 2. And that means x is 5. Do parallel lines ever touch? No. We need to find y. So I'm going to ask a couple questions about this and see if we can figure out how to set up an equation to find y. Parallel lines are never going to touch each other. And I know that this distance right here is the same as this distance right here because we had these 2 congruence marks here. So because those parallel lines are the same distance apart from each other, any other transversal, like this one, that cuts through those same parallel lines, it's going to make congruent segments. So these 2 will also be congruent. These 2? The transversals will touch, but the parallel lines won't. So this isn't the same size as this, because that's between the two transversals. But if I look in between the parallel lines, this is going to be the same distance away as this, only because this is the same distance as this. These are great questions, guys. Keep them coming. All right, so because the parallel lines are equidistant, because the parallel lines are equidistant, I know this from the congruence marks. All other transversals that intersect those parallel lines I know this is a lot of words. You write down what you need to. All other transversals that intersect those parallel lines will be cut into congruent segments. If the parallel lines weren't the same distance away on both sides, then I couldn't do this. I wouldn't know that these two are congruent. But because it's congruent over here, it's congruent over here. So what do we want to do then with these two expressions? Set them equal, yes. So 5y plus 2 equals 2x plus y. What'd you say? Y does equal 2. I see a problem with this equation. It's got two different variables in it. We already know what x is. X is how much? X is 5, so I can put 5 in the place of that x. Then that becomes 10. Let me catch up with you here, but you guys are absolutely right. So 5y plus 2 equals 10 plus y. And then what do I do? Minus y from both sides. I have to be careful here. A lot of students will tell me that 5y minus y is 5. No. How many y's am I subtracting when I say minus y? I'm subtracting 1y. So it's 5y minus 1y, which would be 4y. So 4y plus 2 equals 10. Then we minus 2 from both sides. So that I get 4y equals 8, which means y is 2.
Grade these for participation.
The warm-ups? The notes. I don't grade notes.
You don't grade?
I don't grade notes. But it's really hard to do the homework and the test review if you don't have the notes. On the review, but not on the test. Yes, sir.
Was that talking to you?
Do we what? Do we plug in the x and the y? The directions just said to find x and y. So I can stop right here. It didn't ask me to find the lengths of segments like on that homework that we graded yesterday. They wanted us to find the length of the segment, and then we had to plug it back in. So we will look at some where we have to do some plugging in today. Let's go look at the next problem though, 5a. Because there's something that I see in this problem that I just saw in the last problem. We do have an x. We have parallel lines here. So, do we know that these two segments are the same size? No. They didn't say anything about midpoints here. Do we know that these two segments are the same size? No. In fact, I can look right there and I can tell that this distance is not the same as this distance because one of them is 6 and the other one is 10. So I got to come up with a new way of handling this then. When we have parallel lines, my pen all of a sudden is not working. When we have parallel lines, that are not equidistant, I just had it plugged in, so I don't know what the deal is, but yeah, it probably, like maybe it didn't make a good connection when it was charging. When I have parallel lines that are not equidistant, they split the sides into proportional segments. Yep. You're welcome. All right, so I have parallel lines that are not equidistant here. They split the sides into proportional segments. So what I mean by that when I say proportional segments, x and 12, not x plus 12, that's if I wanted the whole side of the triangle. I'm just looking at the segments made by dividing here. So if I extend this out, I'm looking at this segment and this segment here. Those segments are proportional to the segments on the other side. So the 6 and the 10. So I can set up an equation, x over 12, because those are proportional, is equal to 6 over 10, because those are proportional. When I look at a problem like this where I've got the two parallel lines, I actually, in my head, extend this line out so that it divides and makes this fraction for me, the x over 12 and the 6 over 10. What would I do now to solve for x? Multiply both sides by 12. My handwriting is awful today because my pen is not working right. So I would have x equals, that 12 only distributes up to the 6. What is 12 times 6? 72 over 10. What is 72 divided by 10? 7.2. Yeah, it's usually, on this particular one, cross multiplying might take one extra step, but it's the exact same answer, yes. All right, so this is how I set it up when I've got these two parallel lines. They're not equidistant, so I can't set things equal to each other. I have to set up proportions. And I have to know the segments that are being split by those parallel lines. Part B. Do I have parallel lines again? Yes. I've got this, and I've got this. Over here on this side, it's being split, because here's where the parallel line is hitting that side. Come on. So I could do a fraction like this, but in order to do that, I would have to have these two segments. And I don't know how big either of those is. So I'm going to have to use an old tool that we had that we've used already, where we are going to split this into two triangles. We're going to separate the triangles. When I say separate triangles, I'm going to draw the little one. Let's do that right down here. So here's the little triangle. And then I'm going to draw the larger triangle. How big is this side on the little triangle? 10. How big is this side on the little triangle? 12. Do we know how big this side is? Nope, then I'm going to leave it blank. How big is this side on the large triangle? Look at where I marked. 26 minus x. All right, now for this one, for this side over here, we got to be careful. Do you remember the warm-up where we had those two triangles? If I need this side right here, well, I have the 10, that's from here to here, 2x plus 16, yes, because I have these two bits. So we have to add the smaller segments to get the big side. So I would absolutely do 2x plus 6, and then onto that we would have to add the 10. So that would give me 2x plus 16 for that side. So I'm going to write that in here. 2x plus 16. So separate the triangles. We add the smaller segments to get the big side. Then we will set up the proportion of sides. And solve. So my proportion of sides. What would be proportional to 26 minus x on the other triangle? 12. So that's going to be one of my fractions. 26 minus x over 12 is equal to, what would my other fraction have to be then? What are the other sides that are proportional? 2x plus 16 and 10. 2x plus 16 over 10. Now I have a proportion of sides set up, and now we can solve it. I have x on both sides of the equal sign. It's part of both fractions. So we're going to have to get rid of these fractions. What operation gets rid of fractions again? Multiplication. So we're going to have to multiply. Which denominator do you want to get rid of first? 12 sounds good. It does not matter which one you pick. You have to make a choice. So I cancel out the 12. It's going to distribute to my numerator here. So I would have 26 minus x equals, what's 12 times 2x? 24x. Plus, what's 16 times 12? 192. We still have that denominator of 10 over here. So now we have to multiply by that denominator. So I'm going to multiply both sides by 10. Cancels out my denominator on the right. I have to distribute the 10 to both of these. So I would have 260 minus 10x equals 24x plus 192. What would I do now? Plus 10x to both sides. Absolutely correct. What is 24x plus 10x? 34x. So 260 equals 34x plus 192. Then minus 192 from both sides, which is 68. So I have 68 equals 34x. Then we divide both sides by 34, and we get that x is 2. All right. Let's flip this over. How do I want to approach this problem? Can I just make two fractions from my separated sides? No, I don't have that. I do have parallel lines. I'm going to need to separate my two triangles out here. Let's do the little triangle and the larger triangle. On the little triangle, how big is this side right here? This side right here, sorry. 11x minus 12. Because my little triangle is this guy right here. How big is this side? We don't have that one. This side right here, though, is 3. All right, big triangle. How big is this side? 8. And before I find this side up here, what do I need to do? I need to add. So I have 7. That needs to get added to 11x plus 12. Are there any like terms for the 11x? Nope, so that would just stay 11x. Are there any like terms for the 7? Yes, 7 is a like term with what? Negative 12. Be careful, that's got a minus sign. So what is 7 minus 12? Negative, sorry, I didn't hear the number. Negative 5. So 11x minus 5 is what goes up here. So we separated our triangles. Now we're going to write a proportion of sides. 11x minus 12 would be proportional to what on the other triangle? 11x minus 5. What would my other fraction need to be then? Yep. 3 over 8, absolutely. All right. Tell me what to do next. Multiply by a denominator. Pick one for me. 8. Does it matter which one you pick first? Nope. We're going to go with the 8. So I distribute the 8 just to the numerator. 11x times 8 would give me 88x. And 8 times 12, 96. So 88x minus 96 over 11x minus 5 is equal to 3. Now we multiply by our other denominator, 11x minus 5. It's going to cancel out on the left-hand side. On the right-hand side, we have to distribute the 3. So I would have 88x minus 96 equals what? 33x minus 15. What do I do now? Yep. Let's go ahead and get the x's together first. So I'm going to minus 33x from both sides. 88 minus 33? 55. So 55x minus 96 equals negative 15. Make sure you bring that negative down. What do I do after that? Add 96, sorry. Add 96 to both sides. How much? I'm sorry. 81. Scoot my work over because I ran out of room. So plus 96, plus 96. So 55x equals 81. Divide both sides by 55. 1.47. If the directions ask you to take it out to 3 decimal places, you would take it one more, but 2 decimal places is usually sufficient. Let's look at number 6. What does it tell me in my given information? ST is parallel to QR. I'm going to go add that to the picture because it's not marked. ST is parallel to QR. What do they want me to find? PS. So this is what I'm looking for. I have parallel lines. Yay. Can I set this up where I just do the divided sides and make fractions out of them? Yeah, I can on this one. Because my parallel line can come out like this, and I have this number and this number. I'm looking for this piece, but I have this one. So my fractions, I don't know how big PS is, but that would be the numerator of one fraction. PS over, nope. Yep, PS or X over 6.4 equals 12 over 8.2. To get PS all by itself, multiply both sides by 6.4. So I have to take 6.4 and multiply it to the 12 just up at the top. What is 12 times 6.4? 76.8. We're going to divide that by 8.2. Take it out to 3 places for me. 9.36 or 366, depending on how you round. Part B, last thing we're going to do for today. What do they want me to find? They want me to find PQ. Well, PQ is this whole thing. How are we going to find that?
If PS is 9.365, then we add up 9.365 is 6.4.
Yes, there we go. PS together with SQ is equal to PQ. We know that PS is 9.365. SQ is 6.4. So how big is PQ? 9 point, 15 point. Sorry, I think I heard wrong, or else I just started writing it down wrong. 15.765 equals PQ. Very, very nice work today, guys. The homework that you picked up on your way in the door yesterday is due on Monday. If you need another copy of it, if you didn't get one yesterday, if you lost yours, it's the very bottom paper over in that red organizer by the board. Monday, due on Monday. So work on it over the weekend, bring it in, complete it on Monday.